Hello guys, this is Prime Concept. In this video, I want to quickly analyze some of the terminologies that are used in conic section. We have introduced conic section, we explained what the conic section is. So we want to look at the terms that you would keep hearing whenever we're analyzing the concept of conic section. And trust me, if you understand these terms, when we get to the different conic section, which would include the ellipses, the parabola, the hyperbola, when we get to these things, you would understand these terms when we begin to mention them. That is why you should stick with me in this video to learn the terms. And one of the terms you would be hearing is focus. Focus, which is, I think, singular, then foci for plural. So focus is one term you would always or often hear whenever we're dealing with this. So what is the focus of a conic section? The focus of a conic section is a fixed point on that conic. Just like for a circle, you have a fixed point, which is the center of the circle. So that point remains for a particular circle at a particular location in plane. The point remains fixed. So the focus of a conic is a fixed point on that conic section. So that is focus, a fixed point. So one of the things you want to know is that for the parabola as a conic section, the parabola is made of one focus, while the ellipsis has two foci. The hyperbola also has two foci. So that is one thing you should take note of. And number 2 point is the directrix. Directrix or directrices. Now, directrix is actually a line. So the directrix is a straight line that is perpendicular to the major axis or to the axis of the conic. Now, this is what I mean. If I have something like this and say this is a parabola, the focus would be located somewhere in between or inside that parabola. So a point like this would be called the focus, right? Now, what is the directrix? The directrix is a line that is perpendicular, that is drawn perpendicular to the axis of that conic. Now, you notice that this parabola opens upwards, it opens towards the positive y-axis. So my directrix is going to be a line like this that is perpendicular to the y-axis of that parabola, right? So that is a directrix, a line. Number 3 is what we know as vertex. Vertex. So the vertex is actually a point on the conic that is either farthest or closest to the focus and directrix. The vertex is a point on the conic that is farthest or closest to the focus or directrix. Now, for a parabola, the vertex is actually the turning point of the parabola. So if you look at this parabola, this point, this edge, this end of this is the turning point. So this point is what you call the vertex. That's what you call the vertex of a parabola. While for an ellipse or hyperbola, the vertex are the points where where the ellipse or hyperbola crosses the major axis. That is the vertex. So if I have like this and I decide to draw this is an ellipse. This is an ellipse. So this point where this ellipse crosses the major axis, because this is the major axis. So these points are what we know as the vertex. These are not the vertex because this is the major axis, the x-axis. The longest distance is the major axis. So these points and this point are your vertex, right? Yes. So also number 4 is what we know as our okay, Latus. Okay, let's talk about eccentricity first. Eccentricity. Eccentricity. So what is eccentricity? Eccentricity is denoted with E, small letter E. Eccentricity is a constant ratio. Eccentricity is actually the one of the terms, or is the term that can be used to differentiate different conics. Eccentricity is the term that differentiates a parabola from an ellipse, from from a hyperbola. So it's a very important term. So what is that eccentricity? Eccentricity is the ratio of distance of a point to the focus and the distance from that point to the directrix. So it's the ratio of distance. Eccentricity E is distance from a point to focus over distance. Distance from the point, the same point, to directrix. Directrix. So that is our eccentricity, right? So it's the ratio of distance. So one of the things you want to know is that when the eccentricity is less than 1, if your eccentricity is less than 1, then you're dealing with an ellipse. If your eccentricity is greater than 1, you're dealing with a hyperbola. If your eccentricity is equal to 1, you're dealing with a parabola. And then if your eccentricity is 0, you're dealing with a circle. So these are the things you should know about eccentricity. Then number 5 is our latus rectum. Number 5 is latus rectum. That's our number 5. So what is latus rectum? The latus rectum is a line that passes through the focus and is perpendicular to the major axis, and the latus rectum has its end points on the conic. So latus rectum is a line that goes through the focus perpendicular to the major axis and has its end points on the conic. Now, if we consider this as our parabola, then my latus rectum will go through this focus. You can see it, and has its endpoints on the conic. So this straight line you can see that passes through the focus, that straight line is what we refer to as latus rectum. So latus rectum is a line. So we can always find the length of that line, the length of this line we can always find. So in our videos on parabola, ellipse, hyperbola, we'll give the formula to find the length of the latus rectum. Then number 6 is asymptote. Asymptote. What is the asymptote? An asymptote is also a line. So an asymptote is a straight line that a curve approaches but never touches or crosses. Asymptote is a straight line that a curve would approach but never meet. Now something like this, if I draw my hyperbola, because asymptote is basically applicable to hyperbola. Now, if I draw my hyperbola like this, now a straight line, let's say I'm considering through the origin, this straight line, you notice that this curve would keep approaching it, but it will never meet this straight line. This straight line is what we refer to as asymptote. You can still have another one like this. So we usually have 2 for our hyperbola. So these lines are what we call asymptotes. So these are the terms that we'll keep hearing when we're dealing with the conic section. So do well to understand the concept behind this very well. So when we get to ellipses, parabola, hyperbola, we'll begin to give the formulas or relationship for all of these terms, because each of these has the formula as associated with them. Thanks for watching. If you have followed this video up to this point and you are yet to subscribe, please do well to hit the subscribe button, like this video, comment, and share with 10 of your friends. Tell them this is Prime Concept. Thank you.